Alright, so we are back and we're doing the third page of Graphing Rational Functions Review. And so these are some practice examples to get you ready for your summative. And so we can tell right away just from looking at the equation that our domain is going to be anything, x is going to be anything such that x cannot be -5, and y, the range. Now the vertical asymptote is what makes the denominator equal to 0. Right. So that's going to be x equals -5. And the horizontal asymptote, this is going to go to 0. So it'd be -2. So it's going to be y equals -2. So y could be anything except that y can't be -2. So our graph's going to look like this. Now how would you know that? Well, you know it's first and third. You know it's these quadrants because it's not flipped because A is positive. So you'd make a little table of x and y's. And I'd put something around 5, let's say -6. That'd be -1 minus 2, -3, so -6, -3. So you can find out exactly like what that curve is going to look like. I was doing an approximation here, but you'd plug in some points. So you could say something like -4, -1, so -4, -1. So the curve would be a little steeper, but you get the idea. So you put in points that make sense and connect them, and you know it's going to be asymptotic this way and this way. So in this case, you know it's going to be flipped, so your hyperbola is going to be going this way. And we know up 6. Okay, there's your horizontal asymptote, because as this goes to 0, that's going to go to 6. That's 0, 6. Now, so your vertical asymptote is going to be x equals 0, because that's what makes the deal. What value of x makes the denominator 0? X equals 0. So what value of x makes it 0? 0. And a horizontal asymptote is going to be 6, because you put in a 0 here and you're going to get 6. So the domain is going to be x such that x does not equal 0, and the range is going to be y such that y does not equal 6. And you put some values in here, so if you put 2 in there, you're going to get 5. And yeah, why did I pick that? 2. If I put in 1 in there, I get 4. And so, yeah, you get the idea. So the curve is going to look like this over here, asymptotic down here, and put -1 in here, and you get 8. -1 would be 8, yeah. So the bigger x becomes, the closer it gets to 6. So you know it's going to look like this. And you know it has to come on this side of the y-axis. So there you go. Okay, here's number 3. X-intercept is going to be -7, 0. Vertical asymptote is going to be x equals 2. Horizontal asymptote y equals 1. the whole, or we're going to have no whole. The the domain is going to be x such that x does not equal 2. And the range y such that y does not equal 1. So it's going to be up here and down here, so you can plug in a couple points to get exactly where it goes to if you want. Just give me the general shape. So if you have x and y, you could put in like 3. So 3 would be 10 over 1, so 3 would be 10. So you get the idea. So make it nice and steep. So if you go, the more precise you make it, the better. So let's say negative, let's say 1. 1 would be 8 over negative 1, so 1 would be negative 8. One is going to be 8 over negative 1, yes. So, 1, sorry. 1 negative 8, yeah. X equals 0, 7/2. Let me see if there's that right. X equals, what did I say, 1? So you take your graph and it'll look like this. There you go. And number 4, try to factor this problem out. So x plus 1's add out, which means x equals negative 1 is part of a whole, so the whole is negative 1. And you put negative 1 back in here, and you're going to get 2 over negative 1 minus 1. You're going to get 2 over negative 2, which means negative 1. So you're going to get negative 1 comma negative 1 is your whole. So right there is your whole. You know that right now. Okay, x-intercept. You can't have an x-intercept because the numerator can't equal 0. Vertical asymptote, it's going to be x equals 1. Horizontal asymptote, y equals 0. Domain, well, x could be anything such that x cannot equal negative 1 or positive 1 because of the asymptote of the whole. Y could be anything such that y cannot equal 0 for the asymptote or negative 1 for the whole. Then you make some points. So 2, 2. So we have 2 over x minus 1. So put in a 2 and you get 2. Put in a 3. 3 would be 1. 2, 2, 2, 3, 1. So that guy's going to look like this. So negative, let's try some negatives. Negative 1 would be, negative 1 would be negative 1. You can't have negative 1, that wouldn't work because of the denominator. So check that one out. Try negative 2. Negative 3. Negative 3 would be negative 1/2. You can see what's happening there. 0, they put 0 in there. 0 over negative, so it'd be 0, negative 2. So we can see the graph's going to be asymptotic right there, and then come down here like this. All right. Now, the last couple here. I'll try to do these quickly for you. So you're going to have x plus 2 and x minus 1. I'll just go through them, and by now we can move a little faster. So our hole is going to be at -2. You put -2 back in there, and you're going to get -1. So our x-intercept is going to be -1, 0, or 1, sorry, +1, 0. Vertical, none. Horizontal, none. Domain, x such that x does not equal -2. Range, y such that y does not equal -1. 6. So that means x equals 4 is going to be where the hole is. So it's going to be 4, comma. You put 4 back in here, and you're going to get 2 over -5. So it's going to be -2/5. X-intercept is going to be 2, 0. The vertical asymptotes where the denominator equals 0 is going to be x equals 9. Vertical asymptote, horizontal asymptote, y equals 1. Domain, x such that x does not equal 4 or 9. Okay, and the range y such that y does not equal -2/5 or 1. Number 7, factor that out.